community call. It's an update, technical update by John DeWard on autonomy. So, John, please stop sharing. You bring up your slides and you take it from here.
Okay, let me. Can you see my slides?
Yes.
Okay. So what I want to talk about is autonomy and drilling systems automation. And I'm posing a question. So the final slide actually is a question mark. What is it and what isn't it? So my name's John DeWard. I'm Director Emeritus on DSATs, and I've been with DSATs for quite a few years now. So I think there's a need for autonomy definition and clarification. And the reason I come up with this, and I've talked to Maury Lang about it as well, is that marketing seems to be outstripping reality in specifying what are autonomous drilling systems. And I'll come back to that in a little bit more detail in a later slide. So just to go through what I'll cover, my question is, how can we define autonomy? And I want to look at some definitions and background, look at the levels of automation that's used in the automobile industry from SAE, and then levels of automation taxonomy that come from CESAR and are based back to Parasuaraman and Tom Sheridan. And this is what we adopted in the DSA roadmap. So that's already been put out there. Look at some usage in the industry, and then, as I said, ask the question about the way forward. And here's a definition I have of autonomy. And I've used this and I looked at it and I tried to find where I get it. And I can't remember to date whether I created this or whether I took it from somewhere else. So if somebody recognizes the source, I'd like to know that. But it basically says an autonomous system is one that operates without human intervention. So there's zero human intervention. And it continuously adapts to changes in its environment such that it can achieve its mission. So it stays mission oriented and it adapts to changes in its environment. So it's really a very sophisticated system. Now, what I've looked at here is from the roadmap, we look back at Parasuaraman, Sheridan and Wickens, and they actually have made some very clear statements about the role of humans in automation. And one of them is that most industrial automation experts agree that a completely autonomous system without direct human interaction is not a practical goal. So basically, these human factors experts are saying we won't get to fully autonomous systems. And then there's the Sheridan's 10 levels, which he actually republished as 8 levels. And when I talked to Tom Sheridan about this, he said you need to have enough granularity to distinguish between the various levels. So whether it's 8 or it's 10, he doesn't really push it one way or other. 8 was the later version. And it starts out, as I think most people know, that humans must do it all. And at the top level, it ignores the human. So the computer selects the method, executes the task, and ignores the human. The computer's doing everything. Besides the 10 levels, there are these stages of cognitive function interaction between humans and automation. This was published by Parasuaraman and Sheridan. And it says that the first stage is to acquire the information. And here they've put some subheadings as to what acquiring includes. Analyzing and displaying the information, and then deciding the action to take, and then implementing the action. Now I'd like to jump to some, this slide is the one that Tom Sheridan published back in 2012 when he was looking at the next gen air traffic control system. And what you can see is that he took the 4 cognitive functions of acquisition, analysis, selection, and implementation, and he mapped 2 different systems, System A, which has lower levels of automation, and System B that has high levels of automation. And I think what's interesting here is it did not get to the top level of automation. So this is the next gen air traffic control system which he was working on or consulting to. And then I'd like to pull some lessons from NASA Ames. We were very fortunate in 2016 that DSATs had an event with Alonso Vera giving a keynote speech for an hour, And he comes from NASA Ames. He's the human factors leader of NASA Ames research. Now, at the time, his slides were not released, but I've discovered recently that he actually released 2 presentations, and you can watch them on YouTube. One from October 2016, which covers exactly the same topics he covered for us. And those are actually posted on his LinkedIn profile. And one of the things he talked about was generative adaptive expertise. And one of the things he said is that Toyota is replacing some robots on the factory floor with humans. So humans were coming back in the loop. And basically their reasoning was that when a robot is doing work, the process stops improving. So Toyota wanted to improve the process, and therefore they brought the humans back into the system. Rio Tinto is actually now working on integrating the humans in their robotic mining systems. And basically that's hanging around improvement in non-deterministic environments requires adaptive expertise, which comes from the humans. And from what I recall, it was related to the veins in the rock after they've done the drilling and blasting, that the humans needed to go and look on site to get their mapping correct. And they couldn't rely on just the data they were getting from the drill systems. And here's an interesting plot which shows on the bottom relative strengths of the computer versus the human information processing. So the computers are the triangle on the left here, and the humans are the triangle on the right. This is dated 2015. And as we can see, the steps are skills, rules, knowledge, and then expertise, rising up this scale of uncertainty on the y-axis. And then we can see certain points which have been mapped. And you can see that landing the plane in the Hudson was actually expertise, and this was done by humans. It wasn't done by an automated system. So I think that's a very interesting plot about the relative ratio of humans to computers in uncertainty, again dated 2015. Now here's a version that Alonso Vera put out showing 2035. Now he refers here to the ATM Next Gen research. So that's the same research that Tom Sheridan was involved in. And we have the same steps again of skills, rules, knowledge, and expertise. And here he calls it adaptive expertise. And the relative strengths, the computer has now increased significantly and the humans have decreased. But when we get to high uncertainty, the humans are all in control here. So I think this is a map looking out to 2035 that say humans will still be involved in systems, automation systems, when there's high degrees of uncertainty. And the goal they put out for the Mars mission is to design the human into the process. So focus on how the system will communicate its state to the human so that the human can help in unanticipated situations. And what they really want to tack into is human intuition. So even with a mission like the Mars mission, they're still looking at having humans in the process. And then autonomy in non-deterministic environments. And I think this is very relevant for drilling because we can say that we are in a non-deterministic environment. The Mars rover, its autonomy only acts over 5 to 25 meters. Again, I've taken this from Alonso Vera's presentation. And then the challenge for self-driving cars, which people use the word autonomous, is in the last 5%. What is the role of the humans in these control centers and what information do they have? So there's issues about pure autonomy in those. And then the need for the system to communicate with the humans. And then putting humans in context. As Alonso said, most of the pilot's information comes from his rear end. So he's sitting in the seat flying the plane. And when something happens, it's back to good old human operation. And final thoughts in his presentation was humans will remain important components of complex systems. So they're looking at complex systems at NASA Ames, and I think that we're looking at complex systems with drilling systems. And as such, we might heed his warning here to view it that humans will remain important components and look at how the humans play in those future automation systems. Use human adaptive expertise as much as possible. And again, for high degrees of uncertainty, this is what we need to have. And the human perceptual system as much as possible. with interactions with the big data sets. And then he had a couple of other points relating to this. So I want to look quickly at SAE, who published their driving levels of automation. And this is it. So it's SAE 0, level 1, level 2, level 3, level 4, level 5. And level 5 is highly automated. But actually, it's interesting, they do not use the word autonomous anywhere in this slide. It's levels of driving automation to high levels where the automobile is driving and there's no steering wheel, no pedals. It's a design totally for the automation. So this is one way to describe levels of automation, and it's related to automation. Another way is what we put into the roadmap that we adopted from CESAR. And CESAR is a single European sky air traffic management research. And Luca Save, who was the HF guy on that, gave us this taxonomy, which we then asked his permission to use because we believe that the linkage of pilots with air traffic control is very similar to the linkage of the driller with remote operations. So like I say, we put it into the roadmap, and I believe some people have started to use it. And this basically takes Sheridan and Parasubramanian's work a step further. Now, we have to look here that actually the higher levels of automation are at the bottom and the lower levels at the top. So this is inverse to the way that Sheridan plotted it. But again, we have information acquisition, analysis, decision and action selection, and action implementation. And what's interesting is that in acquisition analysis, it only goes to the level of full automation support. It does not go to full automation action or analysis. Here at decision action selection and action implementation, we get to these high levels of automation. So full automation of action sequence. Each of these boxes actually has a large descriptor related to it that is published in the roadmap. So anybody wanting to go and dig into these and say, what does this high level title suggest or include, then you can go and look at the roadmap and read it. So key issues in transitioning to these higher levels, which we published previously. One is data attribute risk. So John McPherson led a group in the roadmap looking at data, so sensors and data. So IMS, as it's called, instrument management systems, or measurement systems, sorry. And they came out with data attributes that are required for automation. So it's not just quality, it's things like latency, frequency, etc. And then if we look at this and say, okay, we need decreasing data attribute risk. So we need better data to get to higher levels of acquisition analysis. If we have poor data, we can't do that. We need to keep the humans significantly in the loop. And then if we look at operation uncertainty, the lower the uncertainty, the higher the level of automation that we can achieve in the drilling process. And I think that's very logical. And if we look at land drilling in North America, very repetitive, we could expect higher levels of automation than, say, on a very uncertain exploration well in a new basin. And then the other thing we've published is that with this, we require a revised human competency model, because the human is going into supervisory control and is not doing the same kind of process he was doing in the past, albeit his past experience is probably very relevant. And a quick map here that comes from SPE 191408, which was written by Robert Wiley and which I co-authored with him. And we put an example of using this LOAT to actually map levels of automation. So the example here is advisory directional drilling. So medium level support in acquisition and analysis, and then going to decision support in action selection, and then manual. So it's displayed to the directional driller, and the directional driller chooses whether he will implement it or not. And then if we go to automated directional drilling, we go to higher levels. Again, this is inverted scale. So we go to higher levels of automation in the acquisition analysis, and then we go to action selection, action implementation. So I said I'd like to touch on usage in the industry, and I think what I'm seeing, and others have mentioned it to me as well, is there's too much marketing hype. The word autonomous is being bandied around far too often and not in a relevant or proper manner. So here's degrees of autonomy that's been published by a company, and they actually appear to be taking the SAE 5 levels, 0 through level 1, 2, 3, 4, 5. And at this highest level here, they've actually drawn it that it's just push the button, and it achieves defined objectives in any scenario autonomously, managing unexpected circumstances and reaching or surpassing human performance. And this is really a good definition of autonomous, but I don't think there's anything I've shown you so far that would suggest that we will actually get to this level of autonomy in drilling systems automation. So something like this put out there without debate concerns me. And then I did a Google of autonomous drilling, and the top 1, 2, 3 sad faces here aligned with what I found from Google. So there are neuro-autonomous solutions using advanced cloud-based software. Wow, that's really incredible stuff. This is describing drilling systems automation. And a company, I put another, introduces autonomous directional drilling. I don't know that we're there yet. So why are they saying they're introducing it? And then World Oil had an article which was quite incredible. It said an autonomous BHA means fewer directional drillers. An autonomous BHA would mean 0 directional drillers, not fewer. So fewer directional drillers with the word autonomous doesn't match. And then I just saw yesterday a publication, came across an email from drilling contractor, which actually said autonomously automates pipe connections. And I just wonder how you autonomously automate them. It seems a bit strange. The one that gets the smiley face is a particular company that actually has a so-called fully automated drilling rig. And they say built by drillers for drillers, their rig operating system enables advanced drilling automation. So I think that that is a relevant and accurate description, and all of this banding around of autonomous is not correct. What's the way forward? So I asked, can DSATs play a role? And I think so. And the steps I put in here, and it's all full of question marks. It's what can we do? One is probably develop an agreement on a levels of automation taxonomy. Do we adopt SAE? Do we go with the LOAT that came from Cesar? Is there another set of taxonomy that actually describes various levels that would work for drilling systems automation? So can we get a group of people, experts together, and come out and say, this is the way we should be describing it, this is the tool to use? And then to promote that solution through SPE-JPT and IDC drilling contractor, so industry publications, promote it through the DSAT's website, and then I think make videos of key experts discussing the taxonomy. There was a the Drilling Systems Automation website, the DSAT's website, put up a video that I'd actually made, a short video about autonomy and a discussion I made on it. And Michael Bahunek followed up with a very interesting comment of his view about it, which had a lot of his experience written into it. So I would think that asking someone like Michael to make a short video and then use this new system on the website to promote it would have experts saying how they view this taxonomy. And then progress the Human Factors Initiative. There is an SPE DSATs and IDC ART DCS initiative to move forwards on human factors. And it's just starting out now and starting to look at what are the issues that need to be addressed and how could they be addressed. And one of the things that came out of the recent DCS meeting was the human factors expert from BP who made a presentation suggested that the first step could be to develop a guideline to assess humans with automation. And that may be something that this team picks up on. I don't know yet. There's still got to be some meetings around it. But if they do, then is taxonomy part of the solution? And I would probably say yes, because a good taxonomy actually is a way to describe the human interaction with the automated system. And then further questions, what else needs to happen? So thanks for your time. And if anybody's got any questions, I'd be happy to take them.
Thank you very much, John. Very thought-provoking presentation. I have a comment, not a question. Niki Lauda also said that the best way to drive a car is through your rear end.
And he was an expert.
He was an expert, yeah. Any questions for John from anyone, guys? Comments, thoughts? That's the role for this art here, to have these kind of discussions and debates.
This is John.
Raise your hand and I'll kind of steer around. Austin, go ahead, please.
I was just going to ask if you could share the slides, John.
Yeah, I think I can. What I want to do is to double check with Alonso that I'm using his slides with permission. Like I said, I referenced that there are 2 YouTube videos of him making the same presentation, so I think there's no issue. But yeah, I'd be happy to do it, and we'll probably do it through the DSAT's website.
Thank you. John?
Oh, no, that was a really good summary, and I enjoyed it, and I particularly like the slide on autonomous levels. I think it's really worthwhile to sit down and just come up with a really brief definition, like you say, could be a new LOAT, I don't know, but saying, hey, basically uncertainty, autonomy with uncertainty is really doesn't apply. The level of uncertainty we have on our industry, we're not going to get to autonomous systems easily. Yeah? We might be able to have partially autonomous, but we'll still have a degree of supervision if we're. That's a good presentation. I enjoyed it.
Thank you.
Thank you, John. Matt?
Yeah, John, I would appreciate your thoughts. In terms of the drilling and wells interoperability standards, where do you see this, the subject matter you presented, playing into that?
Interesting question. I don't know that they're looking at levels of automation. They're focused mostly, from what I know, on interoperability. I mean, Eric Cailleur's on here, and he may be able to answer that question far better than I can.
Now, I understand what they're working on. I'm curious what your opinion is about the levels of taxonomy and the definition of autonomous. You know, how does that interact with what our standards, interoperability standards could be?
I think if they start to look at the levels of automation, having an agreed taxonomy is the way to map it. So that's how I would see that. I don't know that they're actually, I haven't seen anything from them where they're actually looking at the levels of automation.
Thanks.
Eric.
Yeah.
Yes. So in the glossary of Davis, so I think we have a definition for autonomous drilling, which is very close to the one that you put at in one of the first of the slide, which was about making a decision based on the changing environment. And our definition is taken from a book made by Poole. So you can look into the glossary. I think that there is a reference. But that's the only thing that we have for touching about autonomy. As Matt said, or you said, so we are focused on the interoperability, and we also both look into manual control of operations, automated operations, and also operations where interoperability concerns not necessarily direct control of machine, but advice and things like that.
Yeah, we need to correlate the definitions that we're using in various groups.
Thank you, Eric. Michael?
Yeah, thanks, John, for stitching me up for a web. But I think you bring up, obviously, again, John, some salient points here, especially, I'll say we're kind of in a spurt of growth in terms of what people can now provide at the rig site. And clarity is required here because I think it's important. I remember going way back when, it's kind of similar in a way to when with the multilaterals, right? Just getting our definitions around what was a level one, I mean, each level, what it really was, and the description of that, and setting that helps the communication between folks and some clarity. So even just as a taxonomy to have conversations around what is provided in terms of automation, I think it'd be very useful for us to have and have on our website as a touchstone.
Thank you.
Thank you, Michael. I think Mark Anderson had some comments about autonomous dishwashers. Mark, you want to say something?
No, I think I'll pass on saying anything. Thank you.
Okay. All right. I think that was very interesting, John. Thank you. I appreciate the time. See if you can get clearance for the slides, and then we can share this content.
I saw Robert's got his hand up.
Oh, yeah. Sorry. Go ahead, Robert.
Just a quick comment. I put in the meeting chat. I thought it was a great presentation, John. Very well prepared. And a good update into where we are at the moment. I think that key thing about making those definitions like John and Mike were talking about there is important. I think you also mentioned getting it to the magazines. And I think if we can attack the magazine editors very quickly now, they can get their hands around it and understand if they publish anything, we'll be after their case for not getting it right. So I think it's a great suggestion.
Yeah.
Thank you, Robert.
Excellent. Very good. So